Last theory of 4.3, theory B, misleading charts and diagrams. This is a bit of a weird one as well, because we're not really going to take a look at how new things work. We're just going to take a look at, hey, well, if you want to, you can be very crafty using charts and diagrams and be actually misleading about what you want to tell. And it's up to you to kind of figure out and remember in which different ways actual sources can try to mislead you. This happens in real life. So for example, here we have two different line charts about the same data set. And if I'm going to show you this one, you would say, well, it's a huge increase, right? And then I'm going to show you this one and say, well, not really that big, isn't it? So which one is now the better representation of the data? Well, there are some tips that the book gives you, and I'm going to take a look at some other examples as well. And how they oftentimes try to mislead you. And for example, here they do that by leaving out a part of the vertical axis. Always start at 0 here, and then you will see that indeed that the increase is not as big as you think, because now you're going to compare it to the starting point, and here the starting point, because it's so low, the comparison is going to be a lot bigger. Right, it's going to look like the increase is a lot bigger than it actually is. When examining charts and diagrams, ask yourself the following questions. Is there a clear title that shows what the diagram or chart is about? That's important. Is there enough information along the axis so that the results are clearly visible? So is it very clear what it's about? And does the scale used along the axis give the right impression? The use of a tier line can be important here, right? If you're going to use it, at least use a tier line here. And a very important one that they don't talk about here, because it's not really a mathematical thing, is but check your sources, please. Right? You can expect that everything that's in your numbers and space book is something made up for an exercise. But if you're going to do actual research, and you're going to do that in the upcoming years, don't just believe everything you find out there. And if you're finding a graph of something, don't just think, oh, well, that's a graph that's going to indeed help me in my research. Don't immediately use it. Take a look, where does this chart come from? What data set did they use? If a graph doesn't give you a source, then oftentimes I'm quite wary, because yeah, it could just be made up, right? Let's take a look at some misleading charts, which some of you might actually recognize from previous year, because these were examples that were in the project about international migration, right? For example, the first one, should Britain leave the EU? Well, if you're going to take a look at here, you see that the actual axis here starts at 36%, which means that the difference between 41 and 49% is elevated a lot here. The length of the blue bar is now a lot longer as this one, and that's also indicating that it seems like remain is almost twice or more, is twice as large as leave, which is not the case, right? So you have to start the axis here at 0%, and then you will find two bars which are a lot closer together. For example, this one doesn't seem too misleading. There are multiple things here that you can comment on, but the first one I would say is, if you're going to make a pie chart, or any chart actually, don't make it in 3D, please, because the perspective is going to make it look as if the sectors, the segments that are in the back are smaller than they actually are. So just do it in 2D, please. Don't make this fancy by using 3D images. Another thing that you could say is you don't know what the other sectors here indicates, so that could also be misleading, because remember, those 4 added up are actually almost a quarter. That's quite a lot, right? So it seems like this is insignificant because it's not named, but it could actually be quite significant. Oh, this one, yeah, right. A line chart which goes up and then down, etc. And it seems like the gun that's in Florida rise up and then quickly descend when the stand your ground law is going to be enacted. And stand your ground law is actually a law that made it easier to use your gun when you wanted to defend yourself. And so people said, hey, see, when this law was actually enacted, there were less murders being committed because the line is going down. And then you take a better look and you see that actually for some reason they changed the axis, so the 0 is up here. So this actually means if I go down, there are more murders happening. Yeah, you cannot make it more misleading than this, I think, right? So don't do that. Just put the 0, please, in the left corner. And also, please don't do this 1990s, 2000, 2010s. Just be a bit more accurate on the axis if you do it like this. And this one, in favor against in favor and against a certain result. This is actually used by a political party in the Netherlands. There are multiple things wrong here. First of all, in favor and against, those bars don't add up because the bar here is longer than it should be. So it seems like against is more than twice as big as in favor, which is not the case. Also, if you're going to now color this in a map like this, and that's not really commenting on the graph but more on this drawing here, this is a terrible way to now make this map, because if you're going to color it like this, it seems like a municipality is either in favor or against, right? And that's just not the case. What I would do here, if you only have two things to take on, work with a gradient. So, for example, the more red the gradient is, the more against a certain municipality is, the more green it is, the darker green it is, the more in favor it is. It gives you a much better result. Now, for example, it looks like Amsterdam is entirely in favor, while Rotterdam is entirely against, which is not the case. Work with gradients here. And those are all great skills to work on. They're not just mathematical skills, but they're just, yeah, I would almost say, just skills in life that you should try to work with and also recognize when something is up, when something is skewed in a certain way. And don't just believe it when they give you a map like this and a bar chart like this, because that's will result the way you think about the world, which is not that good. Be critical, please. Okay? Again, an overview of all the words. Know them in Dutch. Next year you're going to do mathematics in Dutch. And that's the end of the chapter. Okay? Good luck preparing. Take a look at some other videos of some homework exercises and prepare well for the tests. Bye bye.